I really like the concept of a frontier. To me, a frontier is a place where your normal intuition no longer applies. The answers are not in the back of the book, and you're going to have to figure things out for yourself. And this makes an environment that's rich in discovery. It makes an environment where the things you learn are going to tickle your imagination and enrich your mind, and then you share them with everybody on earth. And that is the value of going into these frontiers. And another feature of a frontier is that once you start answering questions, you will find that the very questions you asked to begin with were not the right questions that needed to be asked in the first place. And you have to go back to the drawing board and start asking a whole nother series of questions. And what you will find then is questions and answers that feed on each other in a never-ending spiral to knowledge. And this is a characteristic of a frontier. This is why human beings, I believe, are driven to going into frontiers. And this character is what's going to keep human beings from becoming a fossil layer eroding out from some hillside on planet Earth. We will go out into the solar system and colonize other places, and we won't become dinosaurs. Because after all, if the dinosaurs explored the space, if they colonized other planets, they would still be alive today. We're doing research in the frontier low Earth orbit in this weightless environment where we could reduce the local effects of gravitational forces by a factor of 1,000,000 and try to change any other environmental factors by 1,000,000 and see what happens to the nematodes. They're going to just shrivel up and die, change temperature, change pressure, change pH. It's going to have a catastrophic effect on whatever system you're looking at if you change these things by a factor of 1,000,000. But we're changing the magnitude of gravitational forces by a factor of 1,000,000 when we go into this microgravity environment. And the fact that we can go there and basically operate seemingly unchanged, I find that to be an amazing discovery just in itself. But we go there and we make these observations, we make these discoveries that just boggle our minds. We had no idea these things were going to happen. And one example has to do with gene expression in bacteria. We raise bacteria in this microgravity environment, and for some reason or another, they will express different genes and they will have different traits. An example of this has to deal with salmonella bacteria that are being raised on space station, and they're finding that their degree of virulent nature is different from similar bacteria that are raised on Earth. And why? And it's because different gene set is being expressed. And nobody has a clue as to why this is happening right now, but it is happening, and we would never know about it if we hadn't just gone there and done it. Another example has to deal with the rate of diffusion. Early experiments, diffusional experiments in microgravity, wanted to see what happens with the rates of diffusion measurements when you can set up an experiment and make these measurements in a microgravity environment. And they were coming back and finding diffusion rates that were of the order of convection rates. And they were saying, wow, diffusion changes in microgravity. Well, then they started to analyze the data a little closer, and they found out they had designed a diffusion experiment, but because of tertiary effects like Marangoni convection, it's surface tension-driven convection, it was instilling convection in their diffusion experiment, and they were really measuring convection coefficients, not diffusion coefficients. So there's an example where you design this experiment the best you can, you put the experiment in this new environment, you make the measurements. At first you say, wow, everything's different. And then you find out there was some tertiary artifact that worked its way into the experiment that you had no idea would have been important until after you have completed the experiment. So there's an example where you asked a good question, you did the experiment, found the answer, and then you found that the question you asked was really not the appropriate question, and you started in on another series of questions. The whole concept of a frontier, and human beings going into a frontier, where you're no longer living and working in places that have nice manicured lawns and paved streets and sidewalks, and everything works the way it's supposed to work. When you go into an environment like this, it's going to require a high degree of autonomy. You're going to have to be able to work with your crew. You're going to have skill sets so you can keep the machinery that keeps you alive operating. And you're going to have to be able to go through a cycle of questions and answers and questions and answers and spiral into knowledge. And in the process of all of this, you're going to have to keep a sense of humor about the whole process. And human beings are good at doing this. And I have no doubt that human beings will be expanding and placing their DNA every place it's possible in our solar system.